So it's not an F-read or something, or an F-guess?
Okay, let's get started. Welcome to Lecture 7 of 5828, Foundations of Software Engineering. So that means we're at the start of week 4 here, which is the official launch of our presentations assignment. So you've got week 4, 5, and 6 now to work on your first presentation. And haven't been able to get back to the topic spreadsheet in a while. I'm going to do that tomorrow once I've been working on a grant proposal. Once I get that grant proposal out the door, I'll swing back to that spreadsheet. And if there's anything that's pending on that sheet, I'll go through and make assignments and that sort of thing. Yes, question?
So if we signed up for like 4 different topics as of in the very beginning, we'll choose one right away, and then that one can't change. But the other 3 down the line, we can go ahead and start changing or decide to work with other groups on something else?
Totally, yes.
Okay.
Yep, complete flexibility there. It's just that the topic has been approved and then initially assigned. If you no longer want a topic, let me know, and I'll put it back to approved, which would let another student grab it.
Okay.
But I did manage to get my act together this weekend, and as you saw, most likely, I got the homework 2 assignment rolled out, and I got quiz 1 rolled out. So for quiz 1, what you want to do is go to the Desire to Learn website for this class, and there'll be a menu at the top that says, I think, I'm blanking on it, assignments or evaluation or something like that. And click on that, and underneath that it says quizzes. Click on quiz, and you see quiz 1 is now active. And the only thing I'll say about that is that basically if you've been following along on some of the material in basically No Silver Bullet and our Intro to Software Life Cycles and Git, there's some questions on the quiz about those. You only get 1 chance to take the quiz. But you can have as long as you want to take that 1 chance. So there's no artificial time limit on it. But what I would recommend is that you have at least an hour reserved. So you can sit down. You don't have to feel rushed about going back to lecture slides, looking for answers to remind yourself. And that way you can complete the quiz in 1 setting. And then on homework 2, one of the questions requires you to put into practice the things we talked about with Git and to create a Git repo that has this structure. And so you'll want to take a look at that. One of the things I do some recommendations where I say, you can be creating just a single README file like I did in my own example from lecture 2. And you can be using that README file to record the commands you've typed up to that point in the Git repo. So you can keep track of it, because that's actually the end, the last commit, number 14, the only requirement that I really imposed on the assignment was that the README in that commit contains a list of all commands that you typed to create this graph. Now it gets a little confusing when you're on the branches. Which command did I really type? Did I type this on the master branch? Did I type this on the bug fix branch? But if you're really careful and you're thinking about it, maybe if you write it down as you go, or keep track of it in a text file as you go, you should be able to reconstruct those things. So before I launch into today's lecture, I just wanted to make sure, are there any questions about the quiz or homework 2? And I've already got people that have shared the Google Doc with me and shared their repo, so some people just jumped right on it, got it done. That's the other thing that I did in this homework assignment, was to change how you're going to submit things. So I want you to be able to submit your Google Doc that contains all the text-based answers to the questions to me with edit privileges. I'm not going to edit your document, but I'll go in and make annotations, and that's how I'll convey my grade to you. And then the Git repo, I need to be a collaborator on your repo so that I can see it and clone it and take a look at the commit history. Yes?
I didn't actually read yet, but do we have to, you gave a visualization of yours. Mm-hmm. Do we also do that, or just the commits is fine?
Nope, I just wanted to show that it's possible to create the graph. Had a great question and answer with one student who was having a little bit of problems just understanding how the merge command works, and we were able to step through it, and it kind of clarified a few things. So if you have questions, certainly let me know. But some of the Git tutorials that I posted have sections in them that talk about how to delete a commit. So if you make a mistake and you want to go back to where you were at, it's git reset, and you can just specify the commit on the command line, and it will delete that commit. And then you can just pick up from where you left off. So if a merge goes wrong and you've got weird commits in there and you don't have exactly the structure you want, git reset, git reset, git reset back to a state that is good, and then go from there. Okay, but this way you'll come across, I was proud of my graph when I finished completing it, so hopefully you'll be proud of yours. All right. So today, as you know, last Thursday, I didn't quite get through all the slides. There was one chunk of slides at the very end, which was our intro to Agile life cycles. So what I decided to do was just to copy those slides from the end of that lecture, put them at the front of this lecture, and then add more detail about Agile life cycles. So I am picking up where I left off. I just created a whole new set of slides for it. So we had just finished up at the very end talking about the rational life cycle. Rational there is is a reference to a company name, not the actual word rational. It was one that has since Rational eventually got bought by IBM, but it is the life cycle that was created by some famous people in the object-oriented world known as the Three Amigos. They helped to create UML in the first place. Before the UML, Unified Modeling Language, was a thing, they had each developed their own separate notations. So if you look into that area, Grady Booch had his notation, Ivar Jakobsen had his notation, and Rumbaugh had his notation. So there are three competing notations for how to document object-oriented systems in the 80s, late 80s, early 90s, and then all three of them got hired by Rational and were asked to create, unify their notations, and the Unified Modeling Language was the result. Okay, so we had just finished that, and the Rational lifecycle was associated with their approach to developing software systems. Now we're going to talk about the Agile response to traditional software life cycles. So we'll go through the Agile Manifesto and some of the principles. We'll look at the Agile life cycles. I'll list off a bunch of them and then give you an example of one called the extreme programming. And then I'll go on to move some do some additional insight, delivering value to your customer, adopting a customer perspective, adaptive planning, etc. And a lot of this material was culled from previous instances of this class, where I just kind of borrowed material from slides that I gave back in 2012 and some in 2014 and the like. This lecture is going to set us up for actually starting to do reading in one of our textbooks, the software development textbook. So I'll be assigning reading assignments pretty soon. Thursday's lecture is going to be Intro to Concurrency, and that'll set us up for starting to read the chapters in our concurrency textbook. So fairly soon, we've been kind of on hold with our textbooks, but I'm about to change that and let you know a reading plan for which chapter you should read by lectures coming up. Okay, so Agile life cycles are a response to the sort of negative qualities of traditional software development life cycles, and to be quite honest, the negative qualities of the waterfall software life cycle. In those life cycles, there seems to be a focus on creating too many documents and maintaining those documents, a focus on the need for consistency across all documents, having inflexible plans, so creating a plan up front and then having this burning desire to just stick to the plan, even though down the line it seems like it's just definitely not appropriate for what's happening then. There's that phrase, no plan survives an encounter with the enemy, for a reason. You can do your best to plan, but life always changes things on you. In valuing process, so we've got to stick to the process, got to step through it, and valuing that more than the people who are saying, hey, this isn't working, what can we do to get around this problem? And so some of the other problems, seeing the customer as external to the software development team. So in these traditional life cycles, you have the development team somewhere out there as the user, and the two are not considered integrated. You talk to them at requirements, but that's about it. And then finally, of course, everything we talked about in the chaos report, with systems being late, over budget, and producing, being of low quality, having lots of bugs being shipped. So the Agile life cycles came as a response to this, said there's got to be a better way to develop software systems. And instead what they do is they've come up with an approach that focuses instead on communication and collaboration among humans and has the other things sort of fall into place behind that. So, and then a key thing here is that they embrace software engineering practices that are designed to increase developer knowledge of the system that's being created, and therefore your confidence in being able to work with that code base. So the Agile Manifesto, and I put a link to the website that came out in the early 90s, or I guess in the, no, I'm getting my times wrong, the late 90s, early 2000s, and has been up ever since. And it's a very simple page. It just has this statement, and it lists the people who initially signed it, and then it has links to translations in other languages. So they say, we are uncovering better ways of developing software by doing it, building software, and helping others to build software. Through this work, we have come to value individuals and interactions over processes and tools, working software over documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. And so they're not saying that you're going to, in Agile life cycles, you're not going to have contract negotiation, you're not going to follow a plan, you're not going to have processes. You'll have all those things. You'll even make documentation. What they say is that we don't value those as much as individuals, working software, collaboration, and responding to change. So we're going to prioritize those as being more important, things that we value more than those other things. And so this is a big shift, a big shift, a big transformation in the way we would think about building software systems. So from this statement of values, they then subsequently published a paper that identified 12 principles that are important for distinguishing Agile practices from traditional software life cycles. And these days, the situation is much more murky. So if you were to start looking around now, not knowing any of this history, to what people advocate for software development, even in waterfall life cycles, you'll see some of these practices have migrated in. Anything that's low-hanging fruit and easy to follow and makes things better, even the people following waterfall life cycle models will try to bring those in. And so it gets a little bit more murky. But at the time, it was pretty clear-cut. So with the 12 principles, just for sake of time, I'm going to just focus in on 5 of them. And that is deliver early and often, welcome changing requirements. So previously, in previous lectures, I hinted at the fact that people didn't know what to do with changes in requirements. They were problems. And Agile Lifecycle says they're not problems, they're opportunities. They're opportunities to understand what it is that we're building for our customer in a better, more comprehensive way. Face-to-face communication is best. Measure your progress against working software. And simplicity is essential. And then there are, of course, 7 more beyond this that I won't focus on here. Maybe we'll return to them. So for deliver early and often to satisfy the customer, this is the principle that says build a little bit of software that does something, show it to your customer, and deploy it, actually. Let them start using it. Then build a little bit more and show it. Get feedback. If it's not ready, go back and work on it a little bit more, but then deploy it. Let them work on it. Continue on that road. Really big difference, even in the open software, even in the open source software world of, let me understand my requirements, spend a lot of time in the development team just working on the system, and then eventually releasing the software out into the wild, and then finding out what your customers think. Right? It's a big difference in that approach. Now, fortunately, we're starting to see some, well, not some. This is the one I've been using for a while. I haven't gone back to look to see if there's more. But an MIT Sloan Management Review paper published an analysis of software development practices back in 2001. And they showed a strong correlation, not causation, but correlation, between quality of software system and the early delivery of a partially functioning system. And this means, by that delivery, it means it was in the customer's hands, right? Not this, let me show it to you and then take it back with me and not leave it. This is in the customer's hands. And in fact, they found that the correlation was even stronger if the less functional the initial delivery was, the higher the quality of the final delivery. And then that basically comes from the fact that you're getting feedback right away and establishing a good relationship of developing feedback, developing feedback, developing feedback all the way through. And then finally, they found a strong correlation between the final quality of a software system and the frequent deliveries of increasing functionality. And the more frequent the deliveries, the higher the final quality. And some of this can be just put down to the fact that your user, the person receiving the system, is most likely feeling great about what's going on. Like whenever I discuss a change with them, they're not mad or upset. They actually respond and give me that system 2 weeks later. And so your user then is actually in a much better, much happier place. And so then when they're asked to judge the final quality of the system, they'll say, oh, it meets my needs perfectly. It's of the highest quality. Right? So this is what Agile is trying to engender. Customers may choose to put, and so then caveating, putting a caveat on this. I almost used caveat as a verb. That's not, it's a noun. So putting a caveat on this, customers may choose to put initial or intermediate systems into production use, or they might simply review the functionality and provide feedback. And the key thing is this feedback loop, getting feedback all the time from your customer. The next principle is welcome changing requirements. Welcome change and welcome it even late into the project. You're 3 weeks away from your final release, and they change something on you. Don't see that as a bad thing. Embrace it and move with it. And it's really a statement of attitude. Developers in these Agile projects are not afraid of change. They shouldn't be. Changes are good because it means that the understanding of the target domain, whatever domain the user is working in, has now increased. I've learned something new. We were going this way. It turns out that wasn't exactly what they needed. I misunderstood something they said 3 weeks ago. Now I've got a better sense of where we're going, and we can get the system back on track. More importantly, Agile practices, which we'll discuss in a minute with extreme programming, things like pair programming, refactoring, test-driven development, all try to produce systems in which the source code itself ends up being flexible, and thus it is argued is easier to change and easy to change. So you're always in a state of knowing what your extension points are. You know that there's not duplicate code lurking in your system. You've been refactoring it out every time you see it. You've got good knowledge of the system among your team because you're working together while writing the code. You have tests that let you know that as soon as something fails, you know about it right away. So if some change goes in and suddenly something that's been working for months fails, you don't find out about that once you deliver it to them. You find about it as soon as you check in your code and your system runs your tests. And so all these things, all these practices, if you put them into daily use, are self-supporting and get you to that place where you can be open and welcome to change. So face-to-face communication is best. As they say, in an Agile project, people like to talk to each other. The primary mode of communication is conversation with people right in front of you. There is no attempt to capture all the information in writing. Some artifacts are still created, but only if there's some immediate and significant need that artifact satisfies. Once the need is passed, they encourage you to destroy it. And so, for instance, we'll talk about user stories in the weeks to come. User stories are often written on index cards. They like to have a physical manifestation of the story if you can, so you can put it up on a board. You can move it around your environment. This is not being worked on. It's being worked on. It's got problems, etc. But as soon as you've got the user story done, Kent Beck, who is a guy that we'll talk about in a minute, says just take it and shred it. You don't need it anymore. Right? Don't cling to the documentation. Don't get trapped into keeping the old documentation up to date with the current system. Then you're working on the documentation. You're not working on the system. That's what that's the indication there. Another principle, measure progress against working software. So Agile projects measure progress by the amount of software that's currently meeting customer needs. So the project is 30% done if 30% of the required functionality is working and deployed. Right? So this is way different than the waterfall life cycle, in which, let's say, there's 4 major sections. There's requirements, design, implementation, and you include testing and implementation, and then you have your deployment. Right? So with waterfall cycle, if you finish the design phase, you're 50% done. But you haven't written any software yet. Right? So there's no system, but they would claim they were 50% done when they actually weren't done at all. They didn't have anything for that work, in terms of working software. So Agile software says, let's say you have 3 or 4 iterations, 2-week iterations, and let's say for whatever reason, something weird's going on. By the end of week 4, you have produced a couple of prototypes, but nothing has gotten actually into the customer's environment being used yet. You are 0% done in the Agile life cycle. So it has both a positive and a negative. But one thing that it does is it doesn't a lot of these techniques don't allow you to fool yourself. Like, oh, I'm done with the design phase. I'm 50% done. We're making great progress. Right? Whereas with the Agile life cycle, I've got nothing in the customer's hands. It's 0%. I'm working. I'm getting things done, but not to the point where it's actually in their hands yet. And that's going to change how you view your progress, what you do, what energy you put into the project, etc. So we're not measuring progress in terms of phases or creating documents. And then finally, they encourage throughout the projects that simplicity is essential. Always be looking for the simplest thing you could be doing. And they call this the art of maximizing the amount of work not done. So figure out what you have to achieve and what's the simplest way to get it done, and do that. Don't get caught in the trap of imagining problems that might need to be solved and spending time solving those because they haven't manifested as problems yet. You're just kind of wasting time. One example of this in software design is you were told to go implement some small widget. Let's just use a GUI example, a graphical user interface example. You were said, okay, when this process is done, we need a little dialog box that pops up and says this is done, and then the user can click OK or cancel or whatever they need. And most likely you get that thing done in about 5 minutes, right? You go find the right method, you make sure you configure it right, you style it, you get the buttons correct, and you launch it. Up it pops, click OK, you're ready to go. And a simple event handler, wait for the click, and then move on. But you could get trapped into thinking, oh, well, my system is going to need other dialog boxes. Sometimes they'll need to enter text. Sometimes they'll need to have buttons. Sometimes I might want to put an image up there. Maybe a sound to play if something's not right. Change the colors of the fonts if they've entered invalid input. Now look what I did. I just tripled my work, quadrupled my work, just thinking about all those different cases. And the only thing that I had to do was put up a box to click OK. So in Agile life cycles, they would say, don't do any of that extra stuff. Get the box up, click OK, and you're done. Move on to the next thing. That's an actual problem. If it comes up that tomorrow someone says, hey, I need a dialog box where you can type something in, now you've got an actual problem. Go code that. So that's that's what this principle is trying to tell you, is to solve today's problems. Don't try to anticipate tomorrow's problems in terms of the work you're doing. And the underlying belief is that high quality work today will hopefully give us a simple and flexible system that will be easy to change tomorrow if that problem then shows up. And then if it turns out that the rest of your system never needs to interact with the user in any way, you just spent the 5 minutes to get that one dialog box working, and you never wasted any more time on that because it ended up never being, anything else never needed being done. That was oh my God, word salad there. Sorry. You were able to get that done, and you didn't have to do any other work because the need for it never arose. There we go. Okay, so Agile life cycles. There's quite a few Agile life cycles that are out there. We're going to look at extreme programming. Later this semester, we'll look at Scrum. But there are other ones out there. There's lean development. There's Kanban or Kanban. I don't know how to, I think it's Kanban, right? Feature-driven development and Crystal are a few that are out there. There might be more. And our textbook, the textbook I picked for this particular semester, it doesn't really describe any of these in detail. Instead, what it tries to do is to present insight into the benefits of the Agile approach from someone that was a signer of the manifesto and has been a big proponent both in object-oriented world and in the Agile lifecycle world of simplicity and collaboration to get things done. So as a result, since our textbook's going to be more at a high level and kind of, why does this approach work and what are the experiences of someone who's been in it from the beginning, I'll be supplementing like I'm doing today with coverage of additional material from previous versions of the class. And so I've got material on Scrum and other things that I'll reuse as we move forward, user stories, etc. Today we'll just look at extreme programming. So extreme programming was one of the first ones out of the gate, and was developed by someone who was well known in the object-oriented world. His name is Kent Beck. He's a software consultant. And so suddenly Kent Beck started talking about life cycles and process. And then because of his status in the object-oriented world, that kind of got him a big mind share right out of the gate. So this particular approach to developing software was developed during the late 90s when he became a project lead on a system called the Chrysler Comprehensive Compensation System, or the C3 system. It was basically a payroll system. It was written in Smalltalk. The key thing was that the teams before, many teams before, had tried to build this system and failed. They had run way over budget. There was software that couldn't run. It was riddled with bugs, etc. And these systems that had failed previously were ones that were, managed by big corporations, had lots of people working on it, following all the right traditional practices. Should have been something that they could have gotten done. And instead, with a very small team, they were able to very quickly start putting things out that Chrysler could use, and then they kept building and building and building on that until they got to the system that Chrysler could then use from that point on. Now, I doubt that C3 is the system they're using today. They've probably migrated since. But at the time, it was a big achievement, given the fact that the team was so small. Now, the caveat on this particular example is that the team was composed of a bunch of super programmers. These were like top software developers that were working on this particular system. And so you bring a small team of people that know each other and know how to work with each other and have lots of experience individually. Well, of course, they're going to do better than a larger team of less inexperienced ones. But what he tried to do is to summarize his experiences. What were the practices they did? And for small teams, these are practices that they recommend. So the basic idea is that it tries to find standard programming practices or software engineering practices and take them to the extreme. So if testing is supposed to be good, software testing is supposed to be good, let's take it to the extreme. We will write test cases every day. We will, in fact, write test cases before we write code. We will write a testing harness so that we can run the tests every time we make a change. And we will let that drive our development until the tests, we won't be moving on to the next feature until all of our tests are green, as they say. So as Kent Beck says, extreme programming takes certain practices and sets them at 11 on a scale of 1 to 10. So we're going to do software testing? Yes. What's the level we're going to do it at? 11. So, but basically that's kind of the underlying philosophy behind extreme programming. So with respect to the practices that they put in place, there's a bunch of them. I won't get into all of these. But customer team member, user stories, short cycles, acceptance tests, pair programming, test-driven development, collective ownership, continuous integration, run your tests every time, sustainable pace, this one's a great one to talk about, open workspace, the planning game, simple design, refactoring, and metaphor. So these were the main practices. All of these were set to 11. And so this is what I'll give you insight into some of these here. So a customer team member is going directly to that bullet I talked about earlier. The client or your user needs to be on your development team. They need to be sitting in the room with you. So if you ever have a question, something's not clear, you can turn to your user and say, when you said X yesterday, what did you mean? Right, they're right there. Now this was easy to do in the initial C3 context because they were a small team of software consultants working at Chrysler. Right? So of course it's harder to adopt in other situations, and they acknowledge that. But the goal here is to say that both the developers don't think of the client as being external, the user as being external. Likewise, it flips around and puts a responsibility on the user. You're not external either. Get with the program and help us develop the software. Not code, but help us answer the questions. All right, user stories are requirements. So this is something the system has to do, but they're only captured in brief statements. We don't spend our time creating 300-page requirements documents. No one's ever, that's a write-only document. Very often you get into a situation where you're just not reading it anymore. And instead, we keep our brief statements about the functionalities brief enough to put it on an index card, and when we've got it implemented, index card goes bye-bye. Acceptance tests are the practice that, you've got this user story, this is a requirement that needs to be fulfilled. How do we know when it's done? Well, the tests say that it's done. So while you're writing the card, you're also outlining the tests you're going to run, and you get the customer who's on your team to agree if these tests pass, this story is done. Right? And so the user story is complete when the agreed to test cases pass. And of course, if you need to change that, add more test cases, remove it, then you do so as you move along. Short cycles. So this goes right back to iteration, our principle from lecture 1. Too many things can change during development, so plan to release working software every few weeks. They recommend 2 weeks. I've seen other people recommend 1 week. So that's a point of contention. You have to find what works for your organization. But somewhere within 2 weeks, about 10 working days. They were the first ones to really talk about pair programming. They they published in separate books things about pair programming and how to do it. But basically, the one-sentence description of pair programming is all production code, and production code is that code that's deployed and works for the user, is written by pairs of programmers working together. So pretty extreme, right? You're not used to, what do you mean, 2 of us sitting at a computer and only 1 person typing? That's crazy, right? That was the reaction to this. Now, I don't have time to go into it in depth today, but I might find time to bring more of it in later on. But one study back in 2000, 2001 showed that what pair programming did was to reduce the defect rate while very minimally impacting the efficiency. So the first reaction to people saying, oh, I would never pair program, that will slow me way down. Well, the studies that have been conducted show that the team doesn't actually slow down all that much, maybe a little, but not much. But instead, your defect rate, the number of bugs that get out the door, goes way down. And that managers like to hear that. That's like, that sounds pretty cool. And then there's all sorts of variations on pair programming, but the core thing is 2 people working together, 1 person typing and driving, 1 person thinking about what they should do next, what's the test case they should write, thinking at a design level while the other person is typing. Then there's test-driven development. No production code is written except to make failing test cases pass. So your pair of programmers are writing the test cases first, then writing the code, then seeing the test pass. If the test doesn't pass, then writing some more code to make it pass, and then adding another test case to expand the functionality that's needed. And I've got a whole lecture on test-driven development. I'll probably do that later this semester. Collective ownership is that a pair of programmers are allowed to check out any module and improve it. There's no such thing as, don't touch this particular file, that's Ken's file. He gets really testy about it. Do not touch that file, right? None of that's allowed. And if you have a hard time working in that, then agile life cycles are not for you. You should go to a traditional software development company. Because basically the notion is that the system is owned by the team. The team either succeeds or fails. It's not an individual failure. If the project fails, the team failed. So as a result, the team owns everything, and everyone should be knowing what's going on in the software that we're building. Continuous integration is that we build and deploy the system at least once per day, which then helps to identify integration problems early. If we're trying to build a system that we can bring up and show the customer and something dies, then we want to know about that not the hour before the demo. We want to know that because we did it 2 weeks ago and it wasn't working and we fixed it then. And then every day since, as we were adding code, we made sure that we got all the way to deployable system. Right? So again, pretty extreme. Most people don't do this. Most people will type code, run it, maybe write a test case or 2 on just an individual file, but actually doing the steps of getting everything compiled, putting it up on the production server, making sure I can hit it, all that kind of stuff, no. So this was saying, nope, you have to do that. And that continuous integration as a sub-area of software engineering grew as a result. And now there are tools, Jenkins and others like them, that will help you with this process. And it encourages developers to grow a system incrementally. And it's important because Fred Brooks said, most projects, waterfall projects, are on track until they get to integration testing, right? And that's because they've just been delaying and delaying and delaying the inevitable, that the ambiguities in the requirements would finally manifest when we try to integrate. And so this says, no, integrate all the way up here. You have your requirements in design, you just built something, integrate, deploy, integrate, deploy. And do that every day until you get the system done. But another practice is sustainable pace. So we don't want these death marches that you hear about where The deadline is looming. Everyone has to stay and work 80-hour weeks until we meet this deadline. Instead, they go, that's ridiculous. By the end, you're zombies. You're inserting more bugs than you're fixing because everyone's tired, not thinking correctly. So the agile world, the extreme programming world will say, no, software development is not some 5K race where you run as fast as you can. It's a marathon where you pace yourself to make sure that you're meeting your minute goals, your mile a minute, or not mile a minute, but 6-minute miles or 7-minute miles every mile. And that requires a sustained pace, not fast at the beginning and then slow at the end. So you need a sustainable pace of work on your team or you will burn out. So XP teams do not work overtime and they have this 40-hour work week. And I'll say that I see this being embraced by industry, at least in the startup world, because I have friends that I follow on Twitter who work for Twitter, actually here in Boulder, and during their weekends, they're posting pictures of them doing bike rides, out at the farmer's market, what have you, whereas I'm in a coffee shop working on my lecture slides. I'm like, I don't have a 40-hour work week, but they do. XP likes to have an open workspace. This issue, I will say, is very contentious. Some people like to have individual working spaces, offices that they can close off and work in the flow and then have meeting rooms to collaborate. Others say, no, your team should be around a table. They should have a shared environment. If two people working on a system over there suddenly have a problem, we can hear about it and say, oh, hey, what's the problem? We were working on that yesterday. And get knowledge of what's going on throughout the team. So the proponents say that having pairs work near each other promotes team awareness of the current state of the system. The team will just naturally help each other as problems are encountered. But there's a bunch of pushback on this. I've seen developers with very strong opinions that say, no, I don't like the open workspace model. So this one is still out. The planning game is something that we'll talk about in depth in a future lecture. This is where you have your requirements. You know what the current set of requirements are. And with the Agile approach, this is not going to be like you generate 300 requirements, but you generate maybe 15 requirements. But once you've generated those requirements, the team sits down and says, we think this one is a big story, that's a small story, that's a medium story. Or they say, this will take 3 days, that'll take 1 day, etc. They go and they attach an estimate to every story, and that's done by the team. Then the user comes in and says, this is really important, this is medium important, I don't care about this one really, etc. That's where the user comes in and says, these stories now have priorities. And so then what the team works with is what is you want to try to find, as they say, the largest value for work or the biggest bang for the buck, which is what are the high priority stories that have doable point values with them, right? So maybe not 10 points or extra large, but 3 points. Could be done in a couple days, but are high priority. So if we get it done and deployed, the customers can be really happy because a high priority feature is working for them. So you get the estimates on the stories, you get the priorities, and then every iteration you use those priorities and estimates to decide what is it we're going to work on for this particular iteration. All right, and then I mentioned this before, simple design. We emphasize simplicity at all times. We consider the simplest thing that could possibly work and pursue that first. We have the you ain't gonna need it philosophy. So if you're sitting there thinking I could add this extra bell and whistle on the code, don't do it, get the requirement met, and then move on. And then this leads to a bunch of stuff that spills over into software design about don't repeat yourself, which is the DRY principle, once and only once, which means don't have two things in a software system that does the same thing. If you've got two things that are doing similar functionality, merge them, and now you've got one less component to worry about. And that kicks in right in here with refactoring. Refactoring is changing the code so that it's better structured, but the functionality doesn't change. So if I've got a software system that does A, B, and C, and I refactor it, at the end of that refactoring, it still does A, B, and C. I haven't impacted the behavior of the system at all, but I have gone in and cleaned up the code. I got rid of duplication. I made it a little bit more extensible. I made the class names more understandable. There are a bunch of things you could do in refactoring. So I've got a lecture on refactoring as well that we can talk a little bit about. But basically, it's doing maintenance on the code to keep it in a nice, clean, extensible state that's easy to understand, and try to fight what they call bit rot, where you get code to work, you don't look at it for a while, you come back, it seems more complex, doesn't work, it's not the way you remember it, or over time, people took something that was nice and clean and added some cruft. It used to do just one thing, now it does 3 things because that was the easiest place to put the functionality, and no one went in and refactored that out to its own class or its own function later on. And then Metaphor says, make sure to have a theme that it ties the entire system together and can be used to discuss the system's architecture. It can help improve morale. So some teams will go all the way and have code names, and all the different internal aspects of the system will fit the theme. And people will say, I'm working on this part of this project. I don't have, I'm horrible at generating metaphors, and I don't have examples right at the top of tip of my fingers, so I'm not going to try to generate one on the fly. But basically, this is just a morale boost. How do we think about this system, and how does my work tie into the metaphor that we have for the system? I'll look for some examples to give you down the line. So that was just a brief insight into extreme programming and some of the practices they put in place, some of the principles that they hold. And then I mentioned all those others, Lean and Crystal and feature-driven development, etc., and Scrum. What you'll find is that all of these life cycles have one shared goal for sure. They have lots of similarities across all of them, but the one shared goal is delivering value to your customer. What is it that your customer needs right now, and am I delivering it such that you can use it? Right? That's the key thing. So extreme programming is just one example. Other Agile methods will differ in the way they assemble the team, what practices they have, like Scrum has doesn't have some of the things that extreme programming has but shares many things, but then also adds things like a daily meeting where everyone meets at the start of the day for about 10 minutes and then they go their way just as a check-in on status. So the different life cycles will arrange things in slightly different ways. But they all have one shared goal, and that's delivering something of value to your customer every iteration, no matter what your iteration size is. And the goal is to try to get you to adopt your customer's perspective. What do you want to see? So if you were the customer in this situation, what would you want to see your developers doing? Hopefully building the stuff that you consider the most important, right? So you want to see working code that's showing that the progress is being made as opposed to, say, status reports or design diagrams or the like. So that's basically what Agile tries to do. And actually, the first couple chapters of our textbook go into what does value mean, how do I know it when I see it, how do I organize my work around identifying value and then producing it. And it sounds like this, undefined concept that is too soft, and we don't want to work with it. We don't want to talk about, I don't want to sound like an MBA and say I'm creating value, right? But when you just transfer value to what the customer wants, it becomes easier to swallow, and it becomes easier to plan your development work around. Now, the key question that I've been glossing over is, who is the customer? Right? And the answer, like one of my slides in lecture 1, talked about all the different contexts, development contexts, embedded software development, contract development, web app development, new product development, hardware development. There's all these different development contexts. So the question comes is, who is the customer? Now, one thing I'll say right off the bat, just so that there's no kind of confusion around this, Agile is not for everything. You won't use Agile life cycles for all types of development. Some development projects won't integrate well with the Agile practices, or they won't. At least it'll be really hard. And in fact, in some of the papers you see about traditional companies adopting Agile, the key thing that you'll often see is that there was a heroic manager that played a role. So the heroic manager knew that the larger company still needed all the status reports, needed the design document, needed the requirements document, all those things. The heroic manager would shield the team from all of that by building them themselves and submitting it to the company on time. Behind the firewall being created by the heroic manager, the team was following Agile. So you'll often see that kind of thing going on when they try to bring Agile into a much larger, more traditional environment. So it's not always going to be clear how do we integrate Agile into a place, and it's not always going to be clear who the customer is. But having said that, what you want to do is to be able to identify as best as you can who are the people who are going to use the software I'm about to write. Who's my customer? Who is actually going to use it? And this kind of, I don't know if I have it on this slide, but this basically, oh, I do. So I say, this is very important because sometimes the answer will be hard to pin down. And that's especially clear in contract work. So someone says, hey, I want to pay you to write this software system. Oh, are you using it? No, I have customers. They're going to use it, right? So, but you're going to be interacting only with the person who's paying, right? The customers are off over there somewhere. And so what you have to do in that situation here is how do you get to those end users so you can start getting the information you need to actually guide the correct feature development. So consider a case where you have to develop a website for a small business. The owner of the small business is clearly the customer at first, because he or she is going to provide the requirements, and more importantly, they're going to pay for the work. But once that website's deployed, the customer will shift, right? The customers of that small business become your customers as well. They're the ones who are day in, day out using the software. And they're going to have better information for you than the customer. The owner of the small business will at some point, because at some point the owner of the small business will say, okay, that's in place, that's good. They'll turn their attention to something else. They won't be using the software necessarily day to day, and now you've got a disconnect. You're getting requirements from a person who's not using the software. Agile will break down in that case. So the customer that we like to emphasize and try to identify is who's the user, who is going to be using the system every day. And HCI, Human-Computer Interaction, and CSCW, Computer-Supported Cooperative Work, research shows that systems live or die by how happy the end users, well, that was the phrase that they would say, because there was the people who were paying for it, and that was one category of user, the customer, and then there were the end users, the people actually using the software system. And these systems live or die by how happy the end users are with the system. If there's no uptake, then you've wasted money and time building a system that no one's using. So the customers of the small business in this case are the end users. However, in that initial development project, we don't have access to them. We only have access to the owner of the small business, so we'll have to go by what they say. In the future, they'll be hearing from customers about the utility and the usability of our website, and they will convey that feedback to us. And I just used that very deliberately, the utility and the usability of our website, because any system that we produce has utility, hopefully, and usability. Those things are separate. So just pause real quick, and since I used that there, I'm just curious, from hearing this for the first time, potentially, what's the difference between those two things? So you got the utility of a website. What's that?
What it accomplishes, like functionality.
It's functionality. What does it do? Right? So how can I use it to solve a problem? So what's the usability then?
Like the UI.
It's like the UI, but it's also just fit to the task. How easy does it make the functionality? Is the functionality hard to use, difficult to use, irritating to use, a pleasure to use? I get excited. I get energized every time. Right? Where on that scale is your system sitting? And so those are two very different ways that a system will be judged, how usable it is and what functionality it provides. So keep that in mind as we go forward. Okay, there are other types of customers, of course. The customer could be you. You're the developer, and you're the customer. You're going to be using the system. Markdown is an example of that. I mentioned how this scratched an itch for John Gruber in creating Markdown, because he wanted to be writing in Markdown and then have his software convert it to HTML and put it out on the web. He wanted to write that logic once and then never think about HTML ever again. Right? So he was the customer in that case. But it's usually only for small-scale software where this works. What's really cool, though, about this is that most open source systems start from that. One person scratching an itch and then saying, hey, it's getting too big for me, I need help, and open sourcing it and bringing in a community around it. So it can be a great way to bootstrap a project. The problem is, of course, that you self-select on what's this system for? Oh, developers, right, because you're a developer. So if you start this way, it's often not because you're launching the next system for, I don't know, some other class of users. You're clearly doing something that scratches an itch for a developer, and then that's going to limit your audience downstream. Another type of customer is the CTOs of companies. They're chief technology officers. They're the ones that are acquiring enterprise-level systems for their organization. So they're the ones that are going to be paying the bills. They're the ones that are going to be telling you what the requirements are for their organization. And just like the small business owner and their customers, we're in the same situation. The CTO is giving us the requirements, paying for the system, but may not be the end user. Right? It's going to be workers, frontline workers in their organization that'll be using the software. And so you have to make sure that they're aware of that. They should be aware of it, given their most likely their development background getting to that position. And so then you're going to have to say, hey, it's great talking to you and getting those things, but can I meet with some people in your organization? Can I get some feedback from them? Can we show the prototypes to them too? Because otherwise we're not getting the direct requirements. And then you have new application development, whether that's for a desktop app, a mobile app, a web app. For version 1, most likely your development team will be yourself. Like I said, it's not always the case where you can bring a user in right from the beginning, because some people like to develop an app in secrecy and then make a big splash when it's ready to go out. Right? So if you're doing that, you either have to have someone close to home who's an actual user of what the system will be, like a best friend or a family member, and they're your customer during that initial phase. And then you release, and then boom, you get out to the larger set of users, and then you'll get more direct feedback on that. So it's not always the case that your situation will match this goal of having the customer be on the development team. And so you have to do some bootstrap before you can get to the actual users. All right, so benefits from adopting a customer perspective, why it's beneficial to you as a developer to be thinking in terms of the customer. One is that you're going to be, a customer wants to see progress, right? So, well, to show progress and keep them happy, your development life cycles should be, your iterations should be short. So deliver incremental sets of functionality every iteration. And that helps let the customers prioritize what you do. You don't have to, you have all these requirements that you could be focusing on. Let them tell you what you're going to try to achieve first. And then you know that if you achieve this high priority item and give it to them, it should deliver some value. It should make them happy. Yes, you let the customer prioritize, help you decide what functionality to focus on, which helps ensure that what you deliver has value. You deliver working software, so this will in turn put a place on things that are considered good practices. You're going to have to put a priority on testing, whereas you might never have done that before. You're going to integrate testing practices in to your own work practice on a daily basis, and that's going to help you catch errors more quickly, and it's going to catch you. It's going to help you guard against new functionality breaking old things. And then you as a person will be seeking feedback. You're always taking the software to someone, getting feedback, and letting that drive your next round of work. And that then allows you to be ready to be, all you're trying to do is to deliver value to this customer as they say, oh, I changed my mind, or I didn't explain this well, here's what actually happens. Those don't become irritations, those become, okay, well, to get to the next point where I'm delivering value, I've got to go in this direction. And it can help you learn how to accept feedback and accept change in a calm way, a way that's opening, as opposed to a combative way. Nope, not going to do that. And that type of skill actually is useful outside of development. It's a very useful skill to have. And it also teaches accountability. So your iterations are short. You've got one or two things you're working on. You deliver it, or you fail to deliver it. If you fail to deliver it, you have to take accountability and say, here's what happened. And own it and say, here's what's going to happen to fix it the next time around. Okay, so the highest priority of an agile life cycle, as I've said now, is meeting a customer's needs via early and frequent delivery of working software. That's like agile in a nutshell. And I'll just say, not everyone likes working this way. You puts you on center stage, so to speak. You're always talking to the customer, getting feedback. Sometimes they're not happy, so you got to deal with that. If you follow the practices, you're on an open work plan. Maybe you like to be by yourself when you're coding. All those kinds of things. It can be very challenging to shift to this style of work. But the benefit is, the benefit that is claimed and has been, is being shown to be true, is that you never drift too far off course for what you're supposed to be delivering. And if you are drifting far off course, the customer lets you know really quickly, and you can correct. So if I go back, I'll come back to that. I got to reorder my slides here. But this slide is now appropriate to that discussion. Oftentimes, if you're not checking in with your customer, this solid line is your customer's needs over time. And eventually they say, yep, you're done. This is the system I needed. So that's where you want to be. If you're not checking in with the customer, slowly but surely you're going to drift off course and deliver something that was true, right? What you actually deliver is what was true over here, right? So, but you said X. Yeah, I said that 6 weeks ago. Things have changed, right? So you delivered me the system I needed 6 weeks ago, but that's not what I need right now. I need something else. And so what Agile tries to do is that, course corrections. Every feedback cycle where you're in front of the customer and getting feedback lets you course correct so that you know kind of just where they're at every time. Oh, you're going over here. Oh, something changed. Okay, we'll course correct on that. Oh, yep, here. So that you're finally narrowing in and converging on the set of features that they need. This is why it's hard. No one's saying it's easy to work in this way. But if you can adopt it, you get closer to this. You're delivering features that your customer wants. So let me just back up because I skipped something, which is that Agile planning, the way we actually structure a software lifecycle across all these different approaches to Agile, so Lean and Scrum and et cetera, have some form of this present in the way they structure the work. It's called Agile planning, and this is a generic way. When we go and look at Scrum, it'll be slightly different, but not too far off different. If you go look at the other ones, again, it won't be very far off of this. You basically, somewhere, have a list of stories that the customer wants. That's your master story list. The Scrum calls that the backlog. I don't like that term, but that's what they call it, the backlog. Every item on the list is a user story, which is a short statement of the user wants to support American Express credit card transactions. The user would like to have, the user can log in and get a status report on the last 10 transactions right away. So it's some desired piece of functionality. And it's a short description of functionality requested by the user. It's not a big, long document. If you look at a story and you go, oh, what were we talking about then? The thing that's written on the card or in the story is meant to trigger your memory to go back to the conversation you had with the user. And then if you can't remember what exactly you were talking about, you call the user, you meet with the user's on your team, and you reestablish that shared understanding and put it back on the board. So you got this master story list. Everything's a user story, which is a requirement. You split your work into iterations that typically go 1 to 3 weeks. If you decide to do your semester project in this class, you'll get to experience what a 1-week iteration is like for 3 weeks in a row. Your iteration, before you start it, you've planned it. You've said these 5 top priority user stories plus this 1 medium story are all going to iteration 1. This next set is going to iteration 2, etc. So you start to assign the stories that you're going to be working on to an iteration. And you assign them according to something called velocity, which we'll return to. But basically, velocity is something you track over time to tell you how much work your team normally gets done in an iteration. So now the very first time you do this, you don't know. You have to guess. So you just say, okay, yeah, we're seeing these. These estimates mean, each point means a day of someone's time. So we got 5 people, so we can probably do 5 points a day. And we work Monday to Friday, so we can do 25 points this iteration. That's something that would be a reasonable way to start iteration. So you'll say, okay, what are 25 points worth of stories? We'll put them in iteration 1, and we're ready to go. If there's 2 weeks in that iteration, you'd take 50 points, etc. It's pretty easy to understand once you've done it the first time. Then you actually track. You say, we picked 50. We go through the iteration. At the end, we've delivered a bunch of functionality, but not everything. So we said our velocity was 50. We delivered 30 points worth of stories. So what Agile does is it says for iteration 2, you have 30 points. That's your velocity. Now you're basing it on the work you actually achieved. It doesn't matter if someone was sick for 2 days. It doesn't matter if there was this weird compiler bug that tripped us up for 1 day. Don't worry about that. You delivered 30 points. Use that to plan the next iteration. If you then on that second iteration get back up to 50, well, then your third iteration will be 50. You track what you actually can do based on what you have been doing. So now if you have too much to do on an iteration, you do less. And that's a key principle and value of Agile that is not present in traditional life cycles. In traditional life cycles, they go, oh yeah, we've got too much to do, we just got to get it done. So 80 hours a week, death march to the end of getting this done, right? That's not what they do. They say, we do less. My time constraint is fixed. My budget is fixed. The only thing that's left to give is what we deliver. So what we call is scoping the iteration. We say, we thought we could do that much. It's not going to happen. We can do this much. And your customer is right there. You can start talking to them to try to figure out, here's what's happening. Here's why this is going on. There's nothing that's going to make us suddenly do 40 more points in this iteration. Here's what's happening. So you do less. And this is called reducing the scope of the iteration, and it's the cornerstone of adaptive planning, which is what this tries to be. Now, I'm not talking about all the iterations that go into this. I'm not talking about iteration debriefs or when and where you do your planning, your estimating, all that kind of stuff. We'll get to that in a subsequent lecture. But this is the key point there. If the budget and schedule are fixed, the only thing that can change is the scope of what you're doing. And you scope it back until you can deliver something that's of high quality and was things that your user wanted. Now, there's things you're leaving on the table, unfortunately, but at least everything that gets delivered is of high quality and were things that the user wanted. Okay, so let's see here. We got 15 more minutes, so we should be able to make this. Okay, so there are 3 facts about software development that, if accepted, can eliminate many of the problems that are encountered in traditional life cycles. So this is the great thing about Agile. In the waterfall model, which remember, the creator of the waterfall model said this is not how you do software development, but we all just ignored that part and ran with it. And the waterfall model says get all your requirements up front. Then move on to design, and then you can go code after that. But what Agile says is there's no way we're going to know all the requirements. It just can't be done. Even if I do the 10 things that you say are the most important for you today and we write those down, there's no guarantee that tomorrow it's the same 10. Things change all the time. So what they try to do is just be upfront about the fact that it's impossible to gather a complete set of requirements, just impossible at the start of a project. It doesn't matter even if you could, because things change. Requirements will change. And there's always going to be one more requirement. The customer will always want one more thing from you. So you have to prioritize and complete what can be done within the constraints of schedule and budget. It's usually easier to get the customer to say, hey, those bells and whistles, we're going to have to drop those for release 1. Because if you wanted me to get that done, I would need to spin up some people, or I would have to go one more iteration. And you know that every iteration costs, I'll just make up a number, $40,000. Every iteration is $40,000. We have to pay salary. We have to pay electricity, all that kind of stuff. That is fixed. And you told me the budget was $200,000. Either you have more money and we can go one more iteration, or we're done, right? That kind of thing. And then what's great about this is that those types of conversations were almost impossible to have in the traditional life cycle. You'd be, now way back here, you signed a contract that said you'd be done on this date by this amount of money. You can't go over it. You agreed that that was what it's going to be. And in the back of your head, you're thinking, yeah, but I was just making up numbers. I had no easy way of making the estimates, right? So I just made things up. And if that goes all the way down your development teams, so they made things up, those made things up, they made things up. Next level, we made things up. Next level, we made things up. The plan really is a bunch of made up numbers. Agile says, basically, if you've got a story that you say can't be done in the next 3 days or within a week, then you probably don't understand enough about the story, right? And you're just guessing anyway. So we're really good at saying, yeah, I can get this done this week, no problem. We're less good about saying, I can get this done this month. And we're horrible at anything else beyond that. And basically, Agile just says, well, let's get out of that context. Let's not try to predict what we're going to do 6 months from now. Let's predict what we're going to do in 2 weeks. We're much better at that. So And this requirement that you gave me that's scary and vague and big, I don't understand it right now. And I think that you don't understand it either. So let's go work on things that we do understand. And maybe as we talk about it, the thing that's currently murky and big will become less big and more defined. And then less big, more defined. And, oh, I can do that in 2 weeks. You just tackle it as more knowledge comes in. So this is the reason why we try to get things scoped way down. We work in short cycles. Our ability to estimate, our confidence behind those estimates goes way up. All right, now I can skip past those slides. I already talked about it. So then I've already mentioned this. We'll just emphasize it once again. When are you done? The progress, again, is with working software. So a user story is done when the functionality it describes has been shipped. It's being used by the developers, being used by the users, not being tested by the developers. And then the project is done when all the user stories that can be completed within the constraints of schedule and budget are shipped. At some point, the money ends, the schedule is done, and you have to call it quits. And so what that means is that every time we tackle, so this is another thing that people don't like about Agile and user stories when they first get into it, is that when you tackle a user story, if you're actually going to give it to a user and let them use it, when you go back to your home or your coffee shop or whatever it is, wherever you code, this means that for that user story, we're going to be doing analysis, we're going to be doing design, we're going to be doing implementation, we're going to be doing testing, we'll be doing integration testing, system testing, acceptance testing, and deployment for that whole story. And so if eventually you get to a point where your system is going to be a database with middleware and a web app on the front end, like that's your final state that you want to be at, or you've got a web service with middleware and then a database somewhere, and your front end is a mobile app which talks to it via a web service. This means that to get that first user story done, you build the database, you find the middleware and you deploy it. You create the web service that's going to take the incoming request. You build the mobile app so that it can do one thing. And it's got a UI, you can log in, you can do things, all to say user story 1 is done. Whereas in a traditional development, we might say, well, we're not going to worry about the UI for 6 months. We're just down here at the database. And just one level above, we'll do some unit tests. Yes, I can insert things. Oh, I can delete things. And that's what we're going to do for the first 6 weeks. With Agile, you can't. You have to do a whole slice, whole vertical slice, because you got to show something to the user. You know, the feature you asked for can be done. And so you get, what's great about this is there's no hiding. There's no pretending, oh yeah, the database will someday magically appear. And oh yeah, we can make a request from the app to the middleware that gets routed to the database and the result comes back. There's no hiding. You got to go and tackle that stuff early. And what's great is if you've got that whole vertical slice for one feature, yeah, maybe it takes you 2 iterations to get there, so your first couple of iterations don't deploy anything, and you're 0% done. But you finally get it all in place. Now, add the next feature. Suddenly you've got your front end is working, your middleware is working, your back end is working, and you can just extend until you get to the full system. So a lot of the work does get front-loaded, but there's no hiding from complexity. The complexity has to be tackled head-on. Okay, team structure, the last thing we'll talk about today. So one of the things that software engineering does all the time in terms of research is how should we structure teams? If we have 10 people coming into a project, who plays what role? Who does what? How do we structure that? In a much larger organization, if you've got 20 teams, each with 10 people, how do we structure them? How do they talk? How do they communicate? If that is just one division of a company that has multiple divisions with thousands of people in each division, how do we structure that? And who gets to talk to whom? Right? And so software engineering literature has talked about this type of research and structuring, and it pulls in social science, it pulls in psychology, it pulls in a whole bunch of different issues that we wouldn't think of as being important for computer science, but there it is. And this goes all the way back to the late 1960s. In Fred Brooks' Mythical Man Month, he has a chapter talking about the chief programmer way of doing things, and he was advocating it. And it wasn't him that came up with it. He was referencing a paper that had come out describing the chief programmer approach to programming. And unfortunately, the chief programmer model has been set aside and is no longer used. It's pretty bad, but they were working on it. And they had lots of roles. Like one of the things was the chief programmer was tasked with getting features implemented so that they could be tested. But then there would be people on the team that were either the apprentice programmer, the assistant, who the chief programmer would train up and give certain tasks to. But there'd be someone that was QA, there'd be another person that was resources, there'd be another person that was the language lawyer, the expert on the language or on the machine that they're working on. So they were thinking of what are all the roles that you need to get the software to be developed successfully. So anyway, in any development life cycle where they assume a team structure, they're going to be talking about different roles: analysts, developers, designers for UI, testers, usability engineers, tool builders, database administrator, language expert, etc. Lots of these things. And what Agile Methods does is it says, well, we're all complex individuals capable of learning lots of things. Let's blur a little bit. We're not going to have just a single person be our UI expert. We should have 3 or 4 people who are UI experts. So we tried to blur, and team members are expected to switch roles and do more than one thing. So the roles in the Agile team blur because the traditional stages of the software development are blurred as well. As I just mentioned, in one iteration, you'll be performing requirements analysis. You'll be doing a design. You'll be fixing bugs for a user story that was deployed on the previous iteration. You might be creating a rapid prototype for one of the stories so you can try to understand it better. And you'll be implementing the design of a 4th user story. Like all 4 of those stories are assigned in this iteration. They might each be at different places. But in that one iteration, you'll be doing a little bit of analysis, some design, some test, some build, etc., and then trying to deliver as many of these stories as possible by the end of the iteration. So analysis, design, implementation, testing, deployment are all continuous things that we do as opposed to distinct things that we do. And I've already talked about the one team mentality. You live and die by the team. You're one team versus a collection of developers. It's not Ken who's responsible for the quality of the add employee feature. It's the team's responsibility. There's no QA department. You are the QA department. Right? You can take on quality assurance roles alongside your development roles. And as a result, there's less structure and there's more responsibility in Agile environments. And that's something I saw just recently. Someone who was complaining about Agile didn't like it at all because there was no way for a person as an individual to advance up the ranks. They were this particular person who was complaining about it was very, it seemed to me to be invested in status. So there was junior programmers, senior programmers, members of the technical staff, right? There was this ranking of how good are you, how long have you been around, and that was very important to that person. They wanted to see those status things go along with the career. And their valid criticism of Agile was to say, well, in this environment, everyone's the same. There's no senior programmer, there's no junior programmer. We're all just developers going right along. And while that's true, those roles are not played out. It's not true that you can't say I've been developing for 30 years. Right? That has value independent of what your title was in the previous job that you were on. And so it's just how you view the status, what is it that you value, what are you looking for on the resume is going to address those types of things. All right, am I out of time? I got 4 minutes. Okay, a couple of things here that I've already kind of touched on, so I'm going to just go over them briefly. Team members should be co-located. We value face-to-face interactions, so as much as possible, your team should be a kernel of people who come to the same place every day. That doesn't mean it has to be cubicles in a business environment, but it often is. I know, however, of whole companies that meet at Starbucks or a coffee shop, and they don't have offices, and they just code while they're at the coffee shop. I've seen that happen. But if you can't pull this off where everyone is co-located, then you better be on a regular basis using social media, video conferences, all the collaboration software that you can to make sure that there's face-to-face time going on between the team members. You need to have an engaged customer. If you don't have a customer or someone playing the role of the customer, if it's your first bootstrap phase, if you don't have actual customers you can talk to, go find another life cycle. Agile is predicated on having an actual end user be part of the team. Okay, and then be flexible. So we learn what our team members can do, and we're also flexible ourselves. So I could be doing this one day, or I could be doing this minute. I could be doing something completely different next hour. I need to be flexible in that. You want to have Agile teams be self-organizing, so you tell them the goal, but you then don't micromanage them and say, you do this, and you do that, and you do this. Okay, you're done with that, go do this. You don't do any of that. You give them a goal, and you let them figure out how they're going to get to that goal. You make them accountable and empowered, so they have the power to make their own choices about the design, but they also have to take responsibility when those choices go wrong. You don't want to say, well, it was this person's fault, the person that can't be here today, it was their fault. You don't want to be able to say that. You want to say, here's how things broke down. I own this. I'll take the lead on getting this fixed at the start of the next iteration, that kind of thing. And you need people to be cross-functional. You have to people that can do more than one thing. You want to have generalists over specialists in these environments. All right, and I think I might have to spill over. I got 2 more minutes. So across life cycles, there tend to be about 6 archetypes for roles for Agile teams: the customer, the analyst, the programmer, the tester, the project manager, and the user experience designer. The customer serves as ground truth, so for the requirements that we've captured in the user stories. If something is ever ambiguous, the customer needs to resolve that ambiguity for us. They're ideally one of the people who will be using the system that's being created, as opposed to a CIO type who might purchase it. They set requirements. They determine what gets built. By setting requirements, they determine what gets built. By setting priorities, they determine what gets built first. And they're the ones who determine. They're the ones that cross off and say, okay, 2 things. They're the ones that say, yeah, this story is done, right? I can see the features implemented now. And they're also the ones that say, oh, we're running out of time, drop this feature. It was really low priority anyway, right? They're the ones that helped do the scope. All right, last thing, and I'll pick up on Thursday. The Agile Analyst is a team role that is oriented more towards the customer. So this is the person who sits down and actually writes the user story, talks to the customer. Hopefully you've got some of the team together while you're doing this, and we'll talk about how to do this in a future lecture. But you've got people who are playing the role of the analyst, trying to understand, now, do you need to do this or that? What happens if this happens? What happens with this corner case? And getting that type of feedback. So a lot of people, when they hear about user stories, go, oh, so what? We got this index card, just says 1 sentence, that tells me how to implement things. No, there's still all the analysis work going on. And as we already said, if you need a document, it serves an immediate need, create it. So if you're having corner case discussions with a user, by all means, write them down, right? And save that, yes. Last minute question.
Is this any different than a project manager, the analyst?
Yes, it's different than the project manager. So I'll have to tell you why on Thursday. I ran out of time. All right, so don't forget quiz 1. If you come to me on Sunday and say, I forgot to take quiz 1, I'll say I'm very sorry for you. But take quiz 1 before Saturday. Yeah, there are 2 questions on Git. So make sure. Yeah.
You want to, if you are able to,
Welcome.
on October 10th?
现在 Git 操作很了解。
Yeah, so